Section 3.4 is about proving trig identity. So what is proving trig identity? So we are doing a proving trig identity. But first of all, what is identity? Identity is an equation. What is equation? Equation is we have equal right in the middle, and then on the left side we have a left hand side LHS, and then we have a right hand side RHS. So basically we pick a side, either we pick a left side or right side, and then we do the math to go to the other side. So this is like building a bridge between point A and point B. So let's say you pick left hand side, which is point A. You pick this one. So that means you are right here. Your job is you have to get to from point A to point B. So that is building a proof. Proof is like building a bridge to connect point A and point B. So you pick a side, I pick point A, and then you have to start building stuff. What is building stuff? Improving identity. Building stuff means you have to use all the identities or all the formulas you know. So for example, if we go up to the first screenshot real quick, we have quotient identity and reciprocal identity. So in the previous lesson, we introduced that the tangent is sine divided by cosine. The cotangent is the reciprocal of tangent, and then the cosecant secant and cotangent, they are the reciprocal of the sine, cosine, and tangent. And then for the even odd identities, the easiest way to memorize this is I know that cosine and secant are even function. That means if you if you put a negative in front of the theta, that means the negative can be cancelled. It's not can be cancelled, it can be removed. So you put a negative in here, in front of the cosine, the negative can be removed. But what about odd? Odd for the sine, tangents, cosecant, and cotangent, if you put a negative in front of theta in the parenthesis, that produce a negative a negative in front of the entire function. So that is odd and even. For the Pythagorean identity, we have sine square plus cosine square equals to 1, and then the tangent square plus 1 equals to secant square, cotangent square plus 1 equals to cosecant. So let's go back to the proof. From point A to point B, do the math is you are going to do the math step by step. Okay, we do this dot dot dot. You are doing algebra until you reach to point B. So we have two rules. Number one is you pick a side, or you pick a more complicated side. More complicated. Why do we have to pick a more complicated side? Because if you pick a side that is too simple, there is nothing you can do. We will get to that in a minute. Number two is do the algebra to reach to the other side. But here is a warning. So the warning, I am supposed to do this in red. So the warning is do not work on both sides simultaneously at the same time. In a proof problem, once you work on both sides simultaneously, basically you are getting a 0. So if the grader sees that you were working on both sides simultaneously, the problem is immediately a 0. Okay, do not work on both sides. All right, so let's start with the first one. So the first problem from 1 to 6, they are the basics, and then problem 7 to 16, they are more complicated. So let's start with number 1. So number 1, we have cosecant theta times cosine theta equals to cotangent theta. So we have a left hand side equals to a right hand side. Which side is more complicated? Of course the left, because the left we have a multiplication. So I am going to pick a side, left hand side, that is equals to cosecant theta times cosine theta. How come I don't pick the right hand side? Because if you pick the right hand side, you start with a cotangent theta. there is really nothing you can do. So for left hand side, cosecant times cosine, I can do some work. First of all, for the cosecant, I can rewrite that as 1 divided by sine. And then for the cosine, cosine is just a cosine. And then now we have a cosine divided by sine. What do we have for cosine divided by sine? We have, look right here, the very first line, cotangent. So that equals to cotangent theta. So that is equals to right hand side. And then I'm going to do something to close this problem. I'm going to do a double slash and then done. This tells me the proof is finished. Look, I start on the left. So this is my left hand side. I told you what the left hand side is. So this is my point A. And then I build the bridge. I do the dot 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 to build my bridge. And then eventually I reach to point B, and this job is done. Again, do not work on both sides at the same time. Do not move the terms from the left to right. You pick a side and then you start working on that side. Okay, it's either you choose plan A or plan B. You pick a plan, then you work on it. You cannot steal anything from the other side. All right, so let me switch back to my pencil, and then we move on to number 2. So number 2, we have a cosine theta, and then times tangent theta plus cotangent theta. That equals to cosecant theta. Which side is more complicated? The left-hand side. So we have cosine theta times tangent theta plus cotangent theta. So that is my side. And then should I distribute the cosine? When you are doing this at home, if you don't know what to do, don't worry. Just be confident. Take a step forward. If you think distributing cosine is fine, just go ahead and do it. If you reach to a mistake, it's not really a mistake. If you keep doing all the work and you still cannot reach to the right hand side, it's fine. Do not erase. Just start on a new page. Okay, just try another plan A and plan B. It will work. Okay, as long as your math is right, it will work. You will be able to reach to the other side. Just don't panic. Be brave. Take a step forward. Work on it. If it doesn't work, that's fine. No panic. Just start another piece of work. So cosine, I am not going to distribute. I am going to rewrite the tangent as sine divided by cosine. And then cotangent, of course, is cosine divided by sine. And then now I am going to get a common denominator in the parentheses for the two fractions. That will be a cosine times a sine. So this one will be a sine square theta plus cosine square theta. Do you see the magic? Sine square plus cosine square is equals to 1. So we have cosine theta and then 1 divided by cosine times sine. One more magic, cosine cancels with the cosine, and I'm going to use a highlighter to do it. Cosine cancels with the cosine, and then what do we have? We have 1 divided by sine theta, that equals to cosecant, CSC, so this is equals to the right hand side, and then we are done. When you do this in your homework or on the test, make your handwriting, make everything very organized, because you don't get credits based on the final answer. You get credits based on your work. If your work doesn't go through, you get a 0. Number 3, we have a secant theta minus 1 times secant theta plus 1 equals to tangent square. Okay, left hand side, more complicated. So you have secant minus 1 and then secant plus 1. That is my left hand side. I know it's annoying to copy this again, but keep a good habit. Do it anyway. It won't take you an hour to copy a short line. So this one, I am going to fully expand the two factors, secant times secant. and then we have a minus secant, and then minus 1. And then what do we have? We have, oh, actually this is a plus because it's a plus minus, right? So the minus and plus is cancel. So we have secant square minus 1. What is this? You don't remember, right? It's fine. We go back, take a look at the Pythagorean identity. Secant square, that's the one in the middle. Secant square minus 1 equals to tangent square. So that is equals to, oops, use the right pen, that is equals to tangent square theta. That is your right hand side, and then the proof is done. Do you need to write the double slash? That would be optional because I get used to it. That makes your work looks pretty cool. Really like it. Alright, moving on to number 4. 1 minus sine theta divided by cosine theta. You may pause the video at any time to work on this. So for example, I write this problem for you, right? That equals to 2 secant theta. If you want, you can pause the video, work it out yourself, and then resume to my video to see if you get the answer right. This one, left hand side, more complicated. So I have 1 minus sine theta divided by cosine. I can do a copy and paste in here, but I choose not to. 1 minus sine theta. And then, common denominator, right? The only thing you can do. So we have a cosine, and then 1 minus sine. So this one we have 1 minus sine times itself, then that will be 1 minus sine times itself, and then plus cosine theta times cosine theta. Okay, and then you expand the top, multiply the cosine, you have 1 minus 2 sine theta plus sine square theta plus cosine square theta. I see the magic. Sine square plus cosine is 1. If you don't want to copy this one more time, I allow you to do some shortcut. You can do this. That is equals to 1, right? And then the 1 is not cancelled. You still have a 1 minus 2 sine plus 1. So you have 1 plus 1 that equals to 2. 2 minus 2 sine, and then divided by cosine, 1 minus sine. Oh, by the way, if you make one little mistake, doesn't matter how small that is, in any way in the proof, you won't be able to reach to the other side. Now, last step, we factor out the 2, and then divided by cosine, 1 minus sine, use my highlighter, cancel these 2, so that equals to 2 divided by cosine. The cosine in the denominator is the same as 2 secant theta. So we reach to the right hand side, so the proof is done. It's not a signature, right? 2 slash done. Moving on to number 5. Again, you can pause the video at any time and do some practice yourself. Number 5, we have 1 minus sine divided by 1 plus sine. And then secant theta minus tangent theta square. This one, I won't do the left because the left there is really nothing you can do. This time I pick the right hand side. So the right hand side, that is secant theta minus tangent theta square. And then you expand that. So just like a minus b square, right? So you have secant square theta minus secant tangent minus another secant tangent. I don't mind to write it out for you. And then plus tangent square theta. Alright, so the minus minus, you have 2 of those. So we have secant square minus 2 of those. And then plus tangent square theta. Okay, look, I am trying to get to the 1 minus sine divided by 1 plus sine. There is no sine in here. So I have to make some sine out. First, the secant is 1 divided by cosine. And then the secant tangent, we can do that too. This is a sine divided by cosine. Do you see a common denominator? Cosine square. So this is a sine square divided by cosine square. Cosine square, cosine square, cosine square, we got our common denominator. So overall, we have, let's see, can we do this in one line? 1 minus 2 sine, and then plus sine square theta. The bottom is cosine square theta. Okay, look, this, let me change the color for now. We have 1 minus 2 sine plus sine square. So this is like 1 minus 2x plus x square. I want to factor this. So the answer is 1 minus x times itself. So put this back to our problem. We don't have x. We have 1 minus sine and times 1 minus sine divided by cosine square. I can't have cosine. Look, take a look at the left side. No cosine. To make some sine out, I have to do 1 minus sine square. This is a Pythagorean identity. 1 minus sine square, right? So this is like, again, I am trying to review your algebra. 1 minus x squared, that is equals to 1 minus x times 1 plus x. Remember this? A squared minus b squared, that is equals to a minus b, and then a plus b. If that is a squared plus b squared, nothing can be factored. All right, we have 1 minus sine, and then times 1 minus sine, and then this is 1 minus sine times, times, yep, 1 plus sine. Can you cancel out something? Of course. Minus, minus. So we have 1 minus sine divided by 1 plus sine. Happy. Take a look. That is exactly what the left-hand side is. So that is equals to the left-hand side. Here is my signature. Double slash. Done. You can draw a happy face if you like. That this exercise is the coolest exercise in the entire subject. The coolest section ever. 6. We have secant theta minus cosecant theta divided by secant theta times cosecant theta equals to sine theta minus cosine theta. Okay, which side? Of course, the left-hand side. So we have secant theta minus, don't be lazy, copy the side. Doesn't matter how long it is, copy it. Just copy, right? Okay, this, we have to use something that you learn from elementary algebra. You know how much I love to do this thing in another color. So let's say you have a minus b divided by c, that is equals to a divided by c minus b divided by c, right? You learn this in elementary algebra. And then there is another big mistake. If you have a c divided by a minus b, let's say you say that equals to a c divided by a minus c divided by b. This is what a big mistake. Not right. You can only break it down into two fractions only if the sign is on top. Doesn't matter that is a plus or minus. Okay, back to this problem. We have secant divided by secant times CSC minus CSC divided by, okay, what's next? Cancellation. secant, cosecant. Oh, actually, nope. Was doing it too fast. This one. Okay. So what do we have left? We have 1 divided by cosecant, right? Which is sine. In case you don't know, secant is 1 divided by sine. You flip the sign back to the numerator. And then secant is 1 divided by cosine. You flip the cosine up to the top. Then you have sine minus cosine. Then that is equal to my right hand side. You have been waiting for this moment. Double slash, your signature, done. All right, let's do one more for the basics. Number 7. So we have a sine theta plus cosine theta square plus sine theta minus cosine theta square that equals to 2. Okay. Left hand side. You have is long. You have to copy it. Okay. Let's fully expand the square. So we have sine plus cosine times itself. So that is sine square theta plus 2 sine times cosine. And then plus cosine square. And then plus sine square minus 2 times sine cosine. And then plus cosine square theta, my magic highlighter. So this and that, they are cancelled, right? And then what else? Ha! Look. We have sine square, cosine, and then another sine, another cosine. Pythagorean identities, right? So sine squared plus cosine squared, basically this is a 1. These two in circle is a 1. We have a plus between them, so that equals to 2. That gives me a signature. Oh, not yet. Right hand side, and then my signature slash, done. You can add a happy face if you like. Alright, so that will be problem 1 to 7. This is the basic. If you're still not familiar with that, take out a piece of paper, work this out yourself, and then you move on to more complicated identities. Alright?